Welcome to this session where we are going to do physics, and the topic we're going to cover is circular or angular motion. So stay tuned as we get to propound this topic step by step for better understanding. The first thing we need to understand, even before we can look at the details of this topic, I would like us to understand what circular motion is. What is circular motion? So we're coming from a background where we did motion in a straight line, which we are calling linear motion. At this point, we are now discussing motion in a circular manner, and we are calling this motion as circular motion or angular motion. So what is it about circular motion? So when you're talking about circular, as the name itself suggests, it is just motion in a straight line, in a circle. Linear is motion in a straight line, so circular is motion in a circle, or should I say in a circular manner. Okay? So basically that is what circular motion is. So we're talking about a situation where I have, this is a circular, let's say, path. Then I have, let's say, an object at point A is moving to point B. Let's say that is my center. I can create an angle there, an angle between A and B. This object will be following this path. Okay? So this object will be following this path, which is circular. But at this point, the velocity will be in this direction, in a straight line direction. So this is taking us now to understand what we need to use under circular and under linear. Okay? So when something is moving in a circular manner, let's say that is the central point, then this is an object at A moving in a circular manner. The velocity at this point is in a straight way or in a straight direction, in the forward direction. But the acceleration always is acting towards the center. Okay? We need to understand that. It is very important. Now let's look at linear and circular or angular motion. Okay? So here I'll say linear motion. Then here I'll say angular motion. Then let me cut on the middle. So the first thing we need to understand, in linear motion, we talk of arc or the distance. Okay? We talk of arc or distance rather. Let me symbolize it by using a letter S. We talk of distance. But under angular motion, what we have is not distance. When you are dealing with angular motion, what we have is angular displacement. Okay, here we have angular displacement, which is denoted by a symbol which is a theta. Okay, under linear motion we have velocity denoted by v, but under angular motion, when you're talking about velocity, under angular motion it is known as angular velocity, and that angular velocity is represented by a symbol which is known as an omega. Okay, that symbol. Then under linear we have acceleration. Okay, calculate linear acceleration. But when you're talking about angular motion, we deal with angular acceleration. Okay, that angular acceleration is denoted by an alpha. Okay, the other thing we can talk of is, so it's still dealing with linear and angular. Let's talk of mass. Under linear we talk of mass denoted by m, but under angular we talk of inertia. Okay, the resistance of an object to move, the resistance of motion. Okay, that is what is known as inertia. Under angular we talk of force, but under linear we talk of force rather, but under angular, when you're dealing with forces under angular, we talk of torques. Okay, torques, those are the forces we deal with under angular. Okay, so it is very important that we understand that, because we'll be using them under equations. Let's look at equations. So there's nothing complex. We'll be doing the linear equations, then translating them into angular equations. They're just one and the same. So we have linear there, we have angular. Okay, so the first equation, let's look at the equation for how we calculate distance. How do we calculate the distance? We say distance is equal to the average velocity multiplied by the time. We say distance is equal to the velocity multiplied by the time under linear motion, right? And this must be the average velocity. Okay, but under angular motion we said we don't have distance. What we have is angular displacement, so it will be equal to, we don't have velocity, so this will be represented by the omega multiplied by the time, and this should be the average what? Angular velocity. Let's look at the next equation. We have under linear, we say final velocity is equal to initial velocity plus acceleration times time. This equation you can write it under angular. Final velocity will be equal to omega final will be equal to initial. So we're going to say initial omega with a naught there plus acceleration. Acceleration we said under angular it is denoted by an alpha. So alpha multiplied by, that is angular acceleration, then multiplied by the time. So this is very important to know, because we'll be using it when solving questions. Then the next thing we can talk of, let's say we want to calculate under linear. We say displacement or distance rather is equal to initial velocity multiplied by the time plus half multiplied by acceleration times time squared. So under angular we can manipulate this equation. Under angular, what are we going to say? So what we're going to say under angular is that distance is denoted by the angular displacement, which will be equal to the initial velocity, so it will be omega initial multiplied by the time, then plus half, we don't have acceleration there, so it will be alpha multiplied by t square. So this is very important for us to understand also. Let's look at another equation. Let's say the way we calculate the equation for when you are dealing with displacement, we say displacement or distance is equal to half then multiplied by initial in brackets initial plus final velocity multiplied by the time. We can manipulate this. Under angular, it will be displacement is angular displacement. This is theta will be equal to half multiplied by initial velocity, then it will be omega initial plus final velocity to be omega final, then everything multiplied by the time. So this is very important for us to understand. Let's look at another equation. We have that one, v squared is equal to u squared plus 2ax. We can manipulate this. Under angular, we can say v, that is final velocity, so it will be final omega final squared, then it will be equal to u, that is initial velocity square, so omega initial with a knot there square, okay, then plus 2, acceleration is denoted by an alpha there, displacement by theta, okay, which is angular displacement. So that is very important for us to understand. Now let's look at a situation whereby we want to calculate the arc length. For example, you have, this is a circle, an object is moving, let's say from A to B, and you want to calculate this arc length denoted by S. So from our mathematics, we say arc length is equal to radius multiplied by theta, right? Arc length is equal to radius multiplied by theta. So we can do some manipulation here. We can do some manipulation here to show the relationship between linear and angular, okay? So let's look at the relationship. So I'll say linear, we are talking about the relationship. I'll say linear versus angular, okay? Linear versus angular. So I just wrote this equation, which is arc length is equal to, or distance rather, is equal to radius multiplied by theta. So this is showing us something. It is trying to relate the relationship which exists between the linear displacement, or distance rather, and also the angular displacement. So it is talking about this relationship, okay? It is trying to tell us, or to show this relationship which exists between linear displacement and also angular. So it's saying linear displacement is equal to radius multiplied by angular displacement. Now let's use this equation to show some relationship which exists, let's say, between linear velocity and also angular velocity, okay? So we are saying, when we are calculating velocity, we say velocity is equal to, when you're dealing with velocity, we say it's displacement over time, right? Velocity is equal to displacement over time. That is the formula you use when you're dealing with displacement. But you see, we are saying S there is equal to R multiplied by theta. So we can substitute R theta there over T. So what are we saying? We are saying V is equal to R theta multiplied by T. But you see, whenever you're talking about omega is given by the formula, which is, so this is velocity there, okay? So V is equal to, so we're trying to relate what is the relationship between linear velocity and angular velocity. Let me just get rid of this, okay? So what we have what we have is this. So what we have is V is equal to R theta over T. Now let's make some manipulation, okay? Let's manipulate something here. So we are saying velocity is equal to radius multiplied by theta, then over time, okay? But we know that this is linear velocity. We're trying to relate it with angular velocity. And from our equation, we said displacement is equal to r theta. This is the one which I have substituted here so that I get r theta, because velocity is equal to displacement over time. Now, I'm trying to relate now what is the relation between velocity and also angular velocity, linear velocity and also angular velocity. What relationship exists between these two things? Okay? So this is what I'm going to do here. So we have omega to show angular velocity. So angular velocity is given by the angular displacement, right? Angular displacement, which we are calling theta, over time. Now let me substitute this theta over time there, where there is theta over time. I'll substitute now this omega. So what I'm going to have is velocity is equal to r, which is the radius, multiplied by, it was theta over what? It was angular displacement over time, but angular displacement over time is just omega, so it will be multiplied by omega. So we need to understand this equation, very important. Linear velocity is equal to radius multiplied by angular velocity. Okay, so let me talk about another equation. We say acceleration is equal to velocity over time, right? Acceleration is equal to velocity over time. That is linear. What is the relationship between linear acceleration and angular acceleration? What relationship exists between these two? Okay, from our interpretation, we've just talked about velocity to be equal to radius multiplied by omega, right? So where there is velocity, I'm going to substitute radius multiplied by omega. Okay, where there is velocity, or rather I can use an alternative whereby I can say, since this is linear acceleration is equal to velocity over time, I can also say angular acceleration, which is denoted by alpha, is equal to angular acceleration. It will also be equal to what? It will also be equal to angular velocity denoted by a symbol omega over what? Over time. So this is the equation when you're dealing with angular velocity, and also this one, angular acceleration, and this one when you're dealing with angular acceleration. Now let me do some manipulation to this formula so that I can get the relationship that exists between linear acceleration and also angular acceleration. So what can we do in order to get the exact value there? What can we do? So this is what I'm going to do here. So we know that acceleration is equal to, so with velocity there, this is linear velocity, right? This is linear velocity. So we have acceleration is equal to velocity over time. Okay, acceleration is equal to velocity over time. But from the previous equation, we said velocity is equal to radius multiplied by omega, which is angular velocity. So where there's velocity there, I can substitute this RW, okay, which is radius multiplied by angular velocity. So I can say R angular velocity multiplied by radius, then everything over what? Over time. So I hope you are following. So this is what I'm doing here. So I have acceleration is equal to radius multiplied by omega over time. This is linear acceleration. This is radius. This is omega, which is just angular velocity, and that is time. So this is what I have at this point. Okay, this is what I have. But from our manipulation or from the formula, we can talk of let's say we can talk of the relationship that exists between the angular acceleration denoted by alpha. Angular acceleration is just more like linear acceleration, but linear acceleration, since linear acceleration we say it is velocity over time, with angular acceleration we're going to say angular acceleration. This one will be now angular velocity, which is denoted by a symbol omega over time. So I can simply substitute that angular velocity over time. I can substitute this angular acceleration. Okay, I can substitute it there. So hope we are following. So this is what I have. So what I have is simply acceleration is equal to radius, where there is omega over time. I can substitute this alpha, okay, alpha, which is angular acceleration. So I'll have the equation angular acceleration, linear acceleration is equal to radius multiplied by angular acceleration. So this equation is very important for you to understand. This is linear acceleration. Okay, this is angular. That is angular acceleration. Okay, so whenever you're dealing with linear, with circular and angular motion, we need to understand that one revolution is simply equal to 360, but 360 in radians is just 3 pi rad. So this is very important for you to understand. Okay, this is very important for you to understand. But when you are talking about, let's say, a situation whereby, or a condition whereby you've been asked or you've been given a situation to say this object in a circular motion, this object here was moving at a constant linear velocity, at a constant. The point I'm trying to put across here is constant velocity. What does it mean? At constant velocity, what you need to understand is that there is zero acceleration. So always at constant velocity, there is zero acceleration. We use this concept when answering questions on this topic. So it's very important for us to understand. Now let's look at centripetal force, because it is very important under circular motion. Centripetal force. So I'll have an illustration whereby this is a circle, then that is the center of the circle, then I'll have, let's say, an object there. This object is moving in this direction. Okay, it's moving in this direction. So the force that pulls this object toward the center, this force is what we are calling centripetal force. But there's also this force which is pulling the object away from the center. Okay? This force which is pulling the object in the opposite direction to the centripetal force. This force is what we call centrifugal. Centrifugal force. So it is very important for us to understand this. So when you're dealing with the forces, under linear we say force is equal to mass times acceleration, right? But when you're dealing with centripetal force is simply equal to the mass multiplied by v square over what? Over radius. When you're dealing with acceleration, this is centripetal force. This is centripetal force. So centripetal force is equal to the mass multiplied by v squared over r. Okay? But what if we're dealing with acceleration? So we've said that acceleration, the acceleration is given by the force over mass, right? That is under linear. We say acceleration is equal to force over mass. But what is the centripetal acceleration? Okay. How do you find the centripetal acceleration? So centripetal acceleration is given by v squared over r. So v squared over r, this is the one which we had to substitute there. Okay? So that to get the centripetal force. So centripetal acceleration is equal to v squared over r. Okay? This is very important for us to understand. Centripetal acceleration is equal to v squared over r. This is very important because we shall use this equation for us to solve questions on this topic. And we said the equation which relates acceleration, linear acceleration and angular acceleration is linear acceleration is equal to radius multiplied by the angular acceleration. So these two equations are very important. So this is basically what you need to understand about circular motion, also known as angular motion. So in the next part now, in part 2 of this video, we shall tackle or concentrate much on the questions. We shall deal with questions and see how we can apply this concept in solving exam questions. See you in part 2.